So I'm Guido van Rossum, creator of the Python language, work at Google since December. Having a great time here. And I thank everyone for showing up so I can do one more dry run of my keynote at O'Reilly's Open Source Conference next week. So that's why the slides do not say Google, but OSCON. Anyway, this talk is about Python 3000. This is slightly more comfortable for me. And let me just dive in with a slight overview of the talk. I'm going to explain a little bit of the philosophy behind Python 3000, so you'll understand where we are in the spectrum between like C++ 09 and Perl 6. And sort of the possibilities of language renovation. Then I'm going to touch on what some people may find the most boring part, which is the actual process that we're setting up to reach the right mix of innovation and conservatism. And then I'm going to do a fairly random selection of things that I expect will be in the new language, which all has to be taken with a grain of salt, since there's a timeline that takes a couple of years probably. And then we'll open a mic for questions. You can interrupt me anytime. After the talk, if there's time for questions afterwards, I would hope that people would use the mic in the middle of the room. So what is the philosophy? I do not want to design a whole new language. Designing a language is a lot of work and a lot of pain and blood, sweat, and tears and all that. And I don't want to go through that again. And actually, I think that Python is pretty good as it is. So my main goal for Python 3000 is actually to sort of fix the relatively small design mistakes I made early on in the language. I mean, Python started out as a definite skunkworks project, done mostly in my spare time in weekends and evenings because I had no life. That's the only way you can get anything significant started in software, believe me. And because I knew that, I knew I had limited time and limited resources, a fraction of myself, I did allow myself to cut some corners. And I tried to cut the corners that were sort of the biggest bang for the buck, and that were actually defensible from a more theoretical perspective, in addition to being helpful in saving me time implementing it. But I did make some mistakes, and some of those were easily corrected. And some of those mistakes were actually really hard to correct because they get at sort of the core of the language in terms of compatibility, and you would break everybody's code by fixing a particular design problem. So Python 3000 is the one opportunity I'm giving myself for fixing those design bugs that require the language to change in an incompatible way and that will break everybody's code. I could choose not to ever do that. I think in the long term, that would be less effective. We'd have a worse language and we'd all be struggling with that forever. At the same time, I'm trying not to sort of do something like Perl 6, where everything is up for discussion. One of the things we're doing is, in the Python 2 series, we're currently at Python 2.5, is about to be released by Neil Norwitz in a couple of weeks, I would guesstimate. Python 2.5 is a very evolutionary step from Python 2.4, as Python 2.4 was an evolutionary step from Python 2.3 and so on. We are trying to get the users to sort of replace certain old idioms with better new idioms. But for backwards compatibility's sake, we leave the old functionality in. Sometimes we issue deprecation warnings to sort of strongly urge people to move on. But for certain things, that would just cause a flurry of deprecation warnings in every single Python program, so it would be useless. And those especially are the things where we make the new features available if we can, using alternate syntax in Python 2.x. But in Python 3000, the new syntax will be the only thing you have. So I have set up what I think is a fairly minimal amount of process for arriving at Python 3000. We need process. I mean, it was clear that if you would just let the community sort of participate unrestricted, we would end up with something that was not like Python, but a completely different language, something that differed more from Python than Lisp differs from Algol. I mean, there are just so many great ideas for language development, and let other language designers sort of explore different ways. There's also the sort of, again, I want to be pragmatic. I want to have something actually in people's hands by a certain date, and I'm setting what now begins to look like an aggressive schedule. And that means that we have to limit ourselves in which things are up for discussion and which things we're going to just say, that's for Python 4000. So some of the questions that we asked ourselves, and I asked the community when I started sort of getting a little more formal about the 3000 process was, well, what is our timeline going to be? And related to that is, are we going to drop Python 2.4 or 2.5 like a hot potato, or are we going to continue to support that? For how long are we going to support Python 2 and Python 3 in parallel? What are we going to do about incompatibilities? How bad can the incompatibilities be? What types of incompatibilities are sort of okay? What kind of things do we want to change, and what is sort of considered the spirit of the language that we should not touch? Then, of course, the question is, what do you do with migrating code from 2 to 3? That's a really, really tough issue, and I'm not claiming to have a complete answer. What we're not going to do, pretty much by definition, is put in backwards compatibility features so you can run your Python 2 code unchanged under Python 3. What may happen is that you will be able to write a dialect of Python that is sort of a large subset that works both in Python 2 and in Python 3. And we'll see what kind of challenges you get there towards the end of the talk. There are a number of things that are completely off the table, things that I just do not want to consider because they're just a big rat hole, a big can of worms, and there's never going to be time to even reach agreement or consensus on the design, let alone implement it. Another thing is, I expect that Python 2 and Python 3 will live alongside for such a long time that actually certain Python 3 features will be merged back into Python 2 in order to ease the transition of code, like in order to make that mutual subset larger. So the release schedule, what I'm aiming at is the first alpha release sometime in 2007, the first actual 3.0 final release will be at least a year after that. Then once 3.0 is in sort of in people's hands, and we're feeling pretty confident about it, that's actually, in some sense, you can consider that another alpha release to a much larger group of alpha testers. And I expect that we'll get lots of feedback that will force us to make some additional changes that are small compared to the differences between Python 2 and 3, but that are still big enough to increment the minor version number. What happened there? I didn't touch anything. Okay, there we are again. The mysteries of PowerPoint on Apple. Okay, so 2 and 3 will be developed in parallel. So I don't want everyone to be holding their breath for Python 3. I mean, you'd get pretty blue in the face. I want to make clear that the Python community is devoted to supporting Python 2 for a very long time while Python 3000 is maturing. So in terms of version numbers, and these versions typically come about 12 to 18 months apart, usually closer on the 18-month side lately. 2.6, which should then be out in a year and a half, which is before 3.0, will certainly come out. I mean, we're already sort of discussing features that were too late for Python 2.5, but are really definitely a good idea. 2.7, probably that's going to be the time frame where we'll start backporting Python 3000 features into Python 2 for easing the transition. After that, it's anybody's guess. My crystal ball gets kind of blurry if you look more than 2 years ahead. I just know that I do not want to go beyond 2.9. At that point, the decimal system and version numbers sort of diverge in an unpleasant way. So, how incompatible will we let it be? Well, we're allowing new keywords. New keywords will always break a small fraction of all code. We're trying to use keywords that aren't too popular as variable names. But it's that easy to detect that kind of breakage because you'll just get a syntax error when you try to compile it, and it's also that easy to do some kind of mechanical translation from programs that use those keywords to some other identifier that at least makes it work. So I have no qualms about adding new keywords. Not that I plan to add a dozen or so, but definitely there will be a couple. The most, well, what I'm guessing is one of the most shocking things that will happen is that keys and range and zip, and especially keys, that's going to be pretty shocking, is not going to return a list anymore. My original thought when I realized as soon as we had iterators and generators in the language at Python 2.2, I realized that keys really should have returned something like an iterator. So my original plan was to do that in Python 3000. Then at my previous employer, I had the opportunity to work with a Java container package for a while, and I actually liked their solution, which is that keys returns an object that is that behaves like a set, but is actually, in terms of implementation, a very shallow view on the underlying dictionary. So that's probably how we're going to approach this. Range, if you're familiar with it, currently returns a list of many integers. We're going to replace that with the functionality that you currently get through xrange, which is something that just remembers what the parameters of your range are and then generates the sequence as you ask for it. Zip is one of those functions. Zip takes 2 or more sequences and then returns a single sequence of tuples containing of sort of parallel items taken from each sequence in order. That should have been an iterator, of course. Unfortunately, zip was introduced in Python 2.0, and we didn't have the iterators then, so it returns a list. So that's, in my view, I think that probably 95% of all usages of zip are actually in for loop, where you say for x, y in zip of list 1 and list 2. So that code will continue to work. Another big change, probably the biggest one in terms of implementation, because it touches almost every piece of code and it touches every extension, is the Unicode transition. We've had about 6 years of experience with Unicode in Python now, and while I was, and still am, reasonably happy with the design we chose originally, I think that sort of we're ready for switching to all strings, being Unicode all the time, and a separate bytes data type that is very specifically not characters. And that's, of course, another idea I stole from Java. Python has never been afraid of stealing good ideas from elsewhere, and I think this is a good one. That, of course, means that we'll also have to redesign the I/O library, and I'll take that as an opportunity to fix a bunch of other problems with the I/O library, because currently it's based on the C standard I/O library, which has some significant problems. For example, you can't switch between reading and writing without some intermediate seek or flush call. If you forget that, the C standard I/O library can actually just segfault or core dump on you. That's okay according to the C library standard. It's not a really great idea in Python, so we have to work around that, which is painful. Another problem with the C standard I/O library that, again, there's no standard way to find out how many bytes it has already buffered, which is not really a question you ask yourself a lot when you're opening a file, but could be very important when you're doing non-blocking I/O on a socket that happens to be connected to a file. So we're taking the opportunity to redesign all that based on a better lower level model and then a stack of things that introduce things like buffering and encoding and decoding in case you want to read and write text files. Very simple, silly case. There should only be one spelling for the unequal operator. On the other hand, a couple of things that have been proposed at some point for that were considered improvements by at least one person, like making dict.keys a plain attribute instead of a method, or changing the else clause on the for loop to be code that is executed if the sequence was empty. Instead of what it currently does, it's executed if the sequence did not, the loop did not end with a break. That would be sort of too weird. Or we're not going to change operator priorities and a whole bunch of other syntactic things. So we did think about migrating of Python 2 code to Python 3. And excuse me. Python being a very dynamic language where there is sort of relatively little syntax, not as little as Lisp, but there's certainly a lot less syntax than in C++ or Perl. There is a lot about a program that you can't easily decide based on what the code looks like alone. Now we have tools like PyChecker that can sort of make certain assumptions about typical human behavior that can deduce a lot better, but the net effect is that they don't have perfect answers. They can sometimes guess wrong. So that's sort of, you don't want to have that in your compiler. Let me take an example of something that's too dynamic for a compiler that just looks at the syntax of your module to get right. If you call some function f with an expression that takes some object x and calls the keys method on that object. Now, as a human reader, I'm going to be pretty sure that that x is probably a dictionary or at least some mapping object. However, there's no real guarantee that that's the case. The other thing is, without actually knowing which function f is, which could be defined in a different module or even in an extension or dynamically loaded, we don't know what f is going to do with those keys. Is it going to iterate over them once, in which case Python 3000 will do just the right thing? Or is it going to assume that it gets a list and start deleting items from that list or sorting it or whatever? Or maybe it'll just iterate over it 5 times or try to iterate over it backwards. That means that it's difficult for a mechanical translator to decide whether this statement needs to be changed into something else or not. And actually, even if f was a function that tried to sort its argument, the correct, I mean, as a programmer, as a human, knowing what the program is trying to do, it might make more sense to say, okay, this function should actually first listify its arguments before trying to sort it. So what we can probably do is write a tool based on PyChecker, or at least very much like PyChecker, but with a specific goal of finding things that will change in Python 3000. So you can run that over your program, and it's probably easily going to find at least 80% of the issues with your code. And it's going to have a bunch of false positives where it thinks there may be an issue where actually you happen to know more about the data that the program is operating on, and you know it's not going to be an issue. It's also going to miss certain things. In order to find more of the things that even a very smart version of PyChecker would miss, there is a complementary approach where you take a Python 2 interpreter, but you instrument it in such a way that it detects situations where objects are used in a way that would be incompatible with Python 3000. One example actually was implemented many years ago when we first introduced the feature of integer division should really return a float. Now, if you write x/y in Python, the compiler doesn't know whether x and y are integers or floats. It just generates a division operator. If you know that they're integers and you want the truncated integer result, you're supposed to be writing x//y, which produces a different operation code that is an integer-specific truncating division. In Python 3000, x/y, when x and y are integers, will actually return float. In Python 2, there is a special thing you can do. You can say from under future under import division, and then in that module, all your slash operators will also produce floating point results when confronted with two integers. And for other types, they will do exactly the same thing as before. Now, what we added to that was a command line option where you could say any occurrences of the slash operator, the division operator, outside the scope of from future import division, we're going to issue a warning if the operands are actually integers at this particular execution. So that the warning will give you the line number and the module where it occurred. Python's warning system is set up so that by default you get each warning only once for each line in each module. So what you can do very easily is you turn on that command line option, then you capture all the warnings about that particular issue in a file, and then you run over that file. And I actually wrote a little script once that took such a file and found the original modules and produced a diff script that turned all those single slashes into double slashes. Now you still have to review that because there could be cases where it's not so easy and you actually want a certain different behavior, but that is certainly a very nice complementary solution to just staring at the source for a very long time until you think you understand what it means. Actually running it and sort of finding out what it's actually doing is a great help. And we can do that for things like that function f called with keys argument, because we can dynamically, whenever we have a list that was returned from a keys operation, we can have a little flag on that list object that says, if you're ever being modified in a way that's incompatible with the Python 3000 API for keys objects, issue a warning. And then we'll know exactly where that's being done. So sort of approaching the problem from both ends, I think we'll have a pretty good solution for migrating code, but it's not going to be 100% automatic. So 5 is right out, one of my favorite Monty Python and the Holy Grail quotes. We actually have a PEP with a funny number 3099 that lists all the things that were once brought up and that are rejected outright, like this is something we're definitely not going to do. For example, there will not be syntax macros or other programmable syntax features. I mean, there are quite a few people who would love that feature and who would kill to have it. It seems there are way more people who would hate it and would absolutely be disgusted if it was ever added to the language. It's sort of difficult to choose, but in this case, I'm just going to choose for what we already have and where my own preference is and where the majority is. A couple of other examples. Parallel iteration, I think the zip iterator will do just fine. I mentioned keys and as an attribute. Some people believe that I made a big mistake by letting iteration over a dictionary return just the keys. I actually really like that feature, so that's not going to change. Well, sometimes I just take the BDFL prerogative and I make an irrational decision, and I'll just say, well, that's because I like it that way. And Usually, eventually, I'll be able to rationalize it when pressed enough. But I like to trust my gut feelings. I mean, I've sort of given into pressure when it went against my gut too often to find out later that actually my gut feeling was right. I just hadn't figured out why. So I'm trusting my gut quite a bit. And it's getting bigger. So I don't want to change the look and feel of the language too much, and I think that so far the examples I've given sort of fit in that general pattern. I don't want to make just random changes. I don't want to make changes that will confuse users. And I also don't want to add radical new features. Now that is probably the one that will be most difficult to keep the community from trying to do, because whenever you say, okay, we're going to create a new version of the language, it's going to be backwards incompatible, everybody feels, I mean, every Python user is in their heart also an amateur language designer. So everybody has an idea for how they could greatly improve their own productivity if only the language had this particular operator. And sort of, if you add all those together, again, you'd end up with worse than Perl 6. And not to harp on Perl 6, it's a great project. It's just sort of an example of something that keeps going on and on and on, and the Perl 5 people are just ignoring it for the most part. So I'm sure that I will give in for some new features that sort of somehow I managed to convince myself are a good thing to have, and Python 3000 is a good opportunity to introduce them. But in general, it's not, apart from the new features that we have to introduce because of changes like Unicode everywhere. I'm sure that's going to give us a bunch of new features, and the I/O library redesign is also going to be a big new feature. But in general, I want to restrict new features because we can, I mean, especially new features that sort of have incompatibles, sort of have compatible new syntax, like they give new meaning to an operator that currently doesn't have any meaning. You can add that anytime. You don't have to have a particular milestone release to do that. So now we get to what everybody's been waiting for. What are actually the new features of the language? And I think I've already given away a bunch. And again, I have to warn that this is definitely a very limited list out of all the possibilities and all the things that I have thought about and the things that I will think about. So all the Python 3000 PEP start obviously with the number 3000, PEP 3000 being sort of the Python 3000 meta PEP that sort of describes the project and explains a bit about the process. Then 3001 and 2 and so on are going to be Python 3000 specific meta PEPs, process PEPs. And 3100 is the first feature PEP. And 3100 is again special because it is a laundry list of features that are currently seriously being considered. And I mean, for most of those, we'll eventually have a PEP somewhere in the 3100s that will describe and specify the feature in much more detail. But at the moment, 3100 is the main laundry list. You are most welcome to join the mailing list, Python 3000. But do understand that if you come up with your favorite radical pet idea, I might frown upon it. You can also follow my blog, which is a much lower bandwidth way for me to disseminate some thinkings and ideas and developments. So there's a whole bunch of basic cleanup. And most of this is listed in PEP 3100. And these are all things that sort of have been in the works for a long time, as these things will change in Python 3000. For example, classic classes. Classic classes were sort of these half-baked user-defined classes that weren't quite exactly as powerful as built-in types. In Python 2.2, I introduced something called new-style classes, which is exactly the same as built-in types in terms of capabilities. However, the new-style classes have a small but significant number of incompatibilities with classic classes, so I didn't want to force everybody to fix their program if it was affected by any of those incompatibilities. So you have to inherit from object or from some other new style class if you want your class to be new style class. At Google, actually, I think most classes in our own code base are classic classes, what I've seen. Classic classes will no longer exist in Python 3000. And all classes will automatically be new style classes. And if you're lucky, your code will still work. And if it doesn't, one of the conversion tools will probably point that out to you. Exceptions. Very early on, Python had strings as exception tokens. That was a bad idea, but the exceptions were actually introduced to the language in the first couple of weeks of its existence, and the classes were introduced only after 9 or 10 months. And I never really got to fixing that until much more recently. So for a long time, we've actually had classes as a possibility for exceptions. Then we converted all the built-in exceptions to classes. In Python 2.5, we're finally converting the built-in exceptions to new-style classes. But you can still use classic classes, and you can still use strings as exceptions. That will no longer be the case in Python 3000. And in addition, your exceptions will now be required to inherit from the base exception class. And traditionally, the base exception class has been called exception. It turns out that there's a good reason for introducing a base that's even more basic than the base. It's called base exception. So technically, you have to inherit from base exception. But unless you understand the difference and you have a really good reason, you should be inheriting from exception. So integer division will finally always return a float. If you want a truncating int, you can write 2 slashes. And you can write those 2 slashes today so that you have the opportunity to do the right thing already. The difference between ints and longs, that's another one of those things where very early on, like in 1990, Python's first year, when it couldn't quite walk, it seemed a good idea to have each type to be closed under all operations and to have integers limited to 32 bits or whatever the machine word length was, and also to have larger integers, but you had to specifically request those. So if you take 2 large 32-bit integers and you multiply them, you would actually get an overflow error. Now, in recent versions of Python, you don't get an overflow error for that anymore. You get a long integer. But because originally short and long integers were separate types, there are a number of operations, especially the things having to do with shifts and octal and hexadecimal numbers. They behave differently. So the same value as a short int sometimes has a different outcome for an operation as the same value in a long int. In Python 3000, there will probably still be a difference in type, but they will behave exactly the same. And we'll do everything we can to sort of hide the existence of the long type from the sort of the average user. C extensions will definitely have to be aware of the difference. But in Python, you will be able to get along without ever writing the word long or knowing about long integers. Everything will just work as if everything was a long integer. Absolute import, by default, there's currently a painful ambiguity when you're inside a package. If you have a submodule in the package that happens to have the same name as a standard library module, you have completely hidden that standard library module from every line of code in that package. Because suppose you had a submodule named sys. Whenever a piece of code in that package says import sys or from sys import something, it's always going to look in the package first and going to find the sys module that you have there, foolishly. In Python 2.5, we're actually optionally fixing that, but you have to use a future statement because there's a lot of code that depends on this. We're going to say you have to specify your own package name, or you have to use special new syntax called relative imports, where you can say from .import sys. But if you say import sys, you will get the new module, and that's going to be the only behavior in Python 3000. Getting access to an exception you just caught. Again, long ago, Python didn't have threads, so it made total sense to have a couple of global variables that saved that information for you. Then we got threads, and we realized that those variables were really hard to keep thread safe, so we introduced a function that sort of pulled the information out of thread local storage. But we didn't throw away the old API. So there's still a lot of code that knows it's not running using multiple threads, especially scripts, that's using the old API. That will go away. Couple of things that have more modern spellings, like dict.hasKey. You can just write if key in dict instead of if dict.hasKey. File.xReadlines at one point was by far the fastest way to iterate over all the lines of a file. Now you can just say for-line in file object. And a bunch of built-in functions that either don't deserve to be built-ins or have better ways of spelling them or have other problems. We're also going to kill a whole bunch of ancient library modules because especially in the first 4 or 5 years of Python, it was pretty much my own personal plaything, and while I shared it with the world starting in '91, for a long time I was I was probably the biggest Python user in the world, and my team were, the other people in my team were number 2, 3, 4, and 5. So we wrote a whole bunch of stuff that was useful for our particular project, which had to do with sound and video, which really didn't belong in the standard library, but we just put it there because it was useful for us. Many of those things are still there, even though they haven't been maintained in the last 10 years. We're going to do a major cleanup of that. Hello? Okay, so we get to the minor syntactic changes. I think the exact statement was a mistake, so it's going to be a function again. Backticks don't look good on in many fonts. They're particularly bad when you're trying to produce PowerPoint slides. So there's a functional notation for that, and we're just going to stick with a function wrapper. We're going to fix an ambiguity in the except handling syntax. It's very it's like an attractive nuisance that you can write except x, y, and you think that you're catching either exception x or exception y, but what you're really doing is catching exception x only, and when you catch one of those, it's going to assign the exception object to the variable y. There's lots of code out there that has this bug because, of course, those exceptions never get triggered. List comprehensions will become syntactic sugar for calling the list function on a generator expression, which is a new feature in Python 2.4. There are very subtle syntactic differences between what's allowed in a list comprehension and what's allowed in a generator expression, that mostly have historical reasons and no particular good reason. So we're going to change that to be the same syntax. Moreover, currently the list comprehension, but not the generator expression, actually bleeds the loop control variable in the surrounding scope. So if you say x for x in S, and you throw away the list comprehension, you still have a variable x that is equal to the last value in that sequence. Assuming, of course, that the sequence wasn't empty, because then it's undefined. So we're not going to do that anymore, because I really like the same feature for for loops. I mean, I write code all the time that goes over some sequence, searching for a particular item, and when it finds it, it breaks out of the for loop, and then after the for loop, I do something with the loop control variable. However, I don't have the same use for list comprehensions bleeding their variables into the scope, so that will be done. And then there are two different ways of raising an exception. You can say raise e comma argument, or raise e and then the argument in parameters, in parentheses. And the latter one is the right syntax. The former syntax only existed, again, because 14 years ago we had string exceptions only. So range will become xrange. Will actually become something like xrange plus plus, because range currently you can actually give it 3 long integers as long as the difference between the top and the bottom one, or the total number of elements in the list, is limited. You can do that with range. Like you can on a 32-bit machine, you can easily write the range from 10 billion to 10 billion plus 5. Xrange currently is limited to short integers. We're going to fix that, and then xrange is going to be renamed to range, and everybody should be happier. Zip becomes what is already known as izip in the itertools library. That's just going to be an iter. I already mentioned that, actually. And it's the same with enumerate, which takes a single sequence and returns pairs of indices and corresponding values. Lambda lives. About a year ago, well, maybe a year and a half ago, I was utterly convinced that lambda had to die. Mostly because there were so many people who complained that lambda was not powerful enough, and you couldn't have like several for loops inside your lambda. Or an if-then-else even, let alone a try-except. And I was almost convinced that, yeah, I mean, a lambda is just syntactic sugar for an anonymous function definition. It doesn't have any new semantics compared to what you can do with a def inside another function. However, when I announced that lambda was going to die, it turned out that lambda has this hardcore following of people who really like it, and they didn't so much try to convince me to put lambda back. They spent a year trying to come up with a better syntax for a more powerful lambda, and they didn't come up with a solution. So I thought to just save them more effort and save everybody pain, that lambda is actually perfectly fine. And if you have the requirement to put several for loops in there, or a try-except, or a complicated if-then-else construction, well, you can just write a nested function, because as soon as it's going to span multiple lines, lambda doesn't actually have all that much advantage over a def. It's the really short ones where you have a lambda that just adds its 2 arguments together, or other simple things where not having lambda is a serious problem, at least for certain styles of programming. So I don't want to hear any more about this. Lambda is going to stay exactly as it is. String types, I already mentioned that we're going to switch to all Unicode all the time. That means that when you specify that something is a text file, you also have to specify an encoding for that text file. Or probably we can use a system default encoding, which in most modern systems these days you can figure out what the system default encoding is. And we shouldn't have to restrict ourselves to ASCII only there. So we're going to have 2 types, one named bytes and one named stir, which roughly take the place of the current stir and the current Unicode, except the current stir is very ambiguous. It's both used for slurping in large amounts of binary data. For example, if you read a GIF file, or you're reading the index of a zip file or a tar file, any number of manipulations of binary data, you store that data in a Python 8-bit string. And you know what it means, and you shouldn't be sort of considering it as characters. For that use, you should be using bytes in Python 3000. On the other hand, if you read text from a text file, like you open a file in text mode, and then you read data from it, and you know that it's like lines of text, then the same 8-bit string type is currently used to represent characters. The problem is that because we don't actually know what encoding is used to hold those characters, everybody has their own idea. Like people in Europe or in the US probably assume that it's going to be ASCII, or are going to assume that it's Latin 1, at least in most European countries. On the other hand, if you're in Greece or Russia or any other country where they use the Cyrillic alphabet, there is another 8-bit encoding that has each byte being one character. And of course, locally, they think that that is the normal interpretation of strings. And then, of course, in other countries, you have multi-byte encodings and UTF-8, and it all becomes much more painful. If you only ever were manipulating 8-bit strings that contain your local default encoding, you can concatenate them and slice them and do a whole bunch of operations and print them, and at the end, everything will still look right if you didn't accidentally sort of cut them in the middle of a UTF-8 multi-character sequence, multi-byte sequence, of course. But you can, if you just sort of read lines and concatenate them, that you're probably going to do okay. However, as soon as you mix these things with Unicode, Python would have to make a choice. Okay, I know what Unicode is. I know every character has a well-defined meaning. But that 8-bit string, I don't know what the bytes mean. I don't know if that 8-bit string contains UTF-8, or if it contains Latin 1, or any of the other, perhaps less popular choices. So Python currently actually decides to not make a choice there and throw an exception, which, of course, is also very upsetting, because you can spend a lot of time testing your code with ASCII data and everything works fine. And unbeknownst to you, at some point, one of your 8-bit strings encounters a Unicode string, and as long as the 8-bit string contains only ASCII bytes, that will work. However, now you deploy your code in the field, and some user types their name, and it happens to have a cedilla or an umlaut. Boom. And that's a very common problem, especially in the web world. So the approach of having all strings be Unicode, and it's too bad that it takes up more space. But at least we are completely rid of the problem of what if bytes and Unicode meet each other. Of course, there will be a new problem, because now you'll have bytes data that you read, and at some point you'll want to turn that into Unicode. But then you have to make an explicit choice, saying, okay, these bytes are going to be interpreted as UTF-8 or Latin 1, or my operating systems or this user's default encoding or whatever. So it's much more explicit about encodings. There's no implicit encoding like we currently have. And you will always know whether you meant to have bytes or characters, because they're actually different types. There won't be a single type that is used both for bytes and for characters. This, of course, means that the I/O library will also change, and the I/O library will actually have slightly different APIs for binary and for text data. Like for text data, you can use readline, but for binary data, we will not support readline. And that gets us into the new standard I/O stack. I think I already sort of mentioned all the problems with the C standard I/O library. Oh, there's also the Windows text mode. And universal new lines, which means that if you open a file in universal new lines mode, it understands all three common conventions for line endings: return line feed, or line feed. But it only does that on input. On output, you still have to use text mode and use your system's convention. Since we're forced to redo the new I/O library anyway, this is going to be fixed, and I hope to learn all the good things from the Java I/O library without making the same mistakes. This work is all still in a very early stage. I mean, in theory, I know very well what the changes are for getting rid of the 8-bit strings and switching everything to Unicode. In practice, that work has to be started yet. The I/O library is even farther away because I haven't spent enough time thinking about what should the API for the I/O library be. And fortunately, there are some people in the Python 3000 community who are interested in helping me out with that. This is a very interesting slide. Last time I gave this at this talk at EuroPython. When this slide came up, everybody booed me. And when I explained what was actually the matter, everybody applauded. So, and pretty much the same thing happened when I first brought this up on Python Dev. So the main problem with print being a statement, apart from it being the only sort of semantic action sort of in the application domain that has its own keyword, is that sooner or later every program ends up having to sort of turn its I/O more into a framework. Like, you start out with a simple script, and when something goes wrong, you print a message and you quit. At some point, you're going to use the logging module. Now you have to find all the print statements and turn them into calls into the logging module's API. It turns out that taking the print statement and turning it into a function call is something that requires a lot of manual labor and is not easily done with some kind of global substitute. Because you have the syntax is so different that, like, even finding the end of the print statement, and then there are things like trailing commas or not, it's just all kind of painful. So we will have print parenthesis and then a number of variables and a closed parenthesis. And that will pretty much behave exactly like the current print statement. You can specify, there's a question.
Will it actually rename the third argument to Z?
Thanks for pointing out the typo there. I'll fix that before I go to OSCON. That's why I do it here first. You can specify to which file it goes, which, by the way, when we first discussed this, some people said, well, why don't we make print a method on the standard I/O library? Then you can just say file.print instead of print with a keyword argument to point out the file. The problem is that lots of people have their own file-like objects implementations that don't have a print method, they have a write method. They would all have to grow a print method, and because Python uses duck typing, they're not all using a common base class that would solve this problem once and for all. So having print as a built-in function, to me, is sort of the right level of support for print at this point. Now, if you want to use some of the fancier features of the current print statement, like the trailing comma, you'll have to use another API, and we haven't decided yet if we're going to introduce something like printf that takes a format string a la C, or maybe something called printraw that just concatenates the arguments as strings and prints that rather than inserting spaces and appending new lines. Dictionary views. I think I discussed all of this already. It will return a set view. This is an interesting one. When I started Python 16 years ago, I knew it was going to be completely dynamic. You could have a list containing an integer, a string, a floating point number, and a function. And for some reason, I thought it was, because lists support being sorted, I thought it was necessary to be able to sort that kind of list with completely random types of elements. It turns out that there isn't actually a really good use case. There's hardly any use case for sorting a list of random elements. There is a very good use case for comparing objects of different types with equality, Is x equal to y? We can ask that even if we know what x is, but we have no idea what y is. If y is a completely different type than x, we'll just say that they're not equal. But if y is a completely different type than x, it's fairly random to decide whether x is less than y or greater than y. And currently, we make an arbitrary decision based on where the two guys are in memory, which, of course, creates problems for Jython, because in Jython, objects can move around in memory. So I think it actually has to choose a different thing, or it chooses where they were in memory originally. It turns out that it's actually much better to just drop the whole idea of every object can be ordered with respect to every other object. If two objects don't specifically implement an ordering relationship between them, it's just going to be an exception, a runtime exception, to try to compare those. And finally, and I see that according to the clock, we're actually close to the end. This is my last slide, my last real slide. This is just an idea, and this is actually one of those new features that may not make it into the language. It has a certain elegance to it. It's actually a really powerful idea. To what extent it is Pythonic, I haven't made up my mind yet. Unfortunately, I didn't actually include a code example in the slide. The idea is that where current classes, of course, dispatch on the type of the object, generic functions, or I like to call them overloaded functions, choose which implementation to use based on the type of all the arguments. You could have a function foo, and you actually have to sort of do the equivalent, the moral equivalent of declaring it as a generic function of a number of arguments. And then you say, OK, here's how foo is implemented when both arguments are integers. Here is how it is implemented when the first argument is a string and the second one is a float. Here is how you implement it for some other combination of types. You can put user-defined types in there as well. Those implementations don't all have to be in the same file. You can have a generic function defined in some common library module, and then two different third-party libraries can each define implementations for types that only that library knows about, and then user application can override those or add another implementation for a particular combination that crosses two or three third-party libraries. The most interesting part of this is that if we actually do this, we solve the problem of adaptation. There's a PEP, and I always forget if it's PEP 245 or 246, that proposes adding adaptation to the language. And several large frameworks like Zope and Twisted have not waited for that PEP to be accepted and have implemented their own adaptation. Adaptation is basically you take an object and a type, and then you say adapt the object to the type, and what it returns is something that either is of the type or at least behaves like that type. And of course, if the object already is of that type, it's a very cheap no-op. You just return the object itself. On the other hand, you could have a registry of, well, if the object is of this particular type, we use this function as an adapter, or this class. If it's of that type, we use that other function or class as an adapter. And again, the idea is that there's a single global registry, and that every module or every library can add to that registry as it feels fit. It turns out that adapt could just be one special case of a generic function. The downside of this is that it feels like a fairly big deviation from what people are used to do in Python. So I'm still on the fence about whether to add this or not. And I blogged about this extensively, so you can read up there also.
Yeah, you mentioned Jython briefly, and I was just curious if there was ever any interest within the Python community of formally committing to supporting a Jython implementation so it could keep up?
Yes, the PSF is actually financially supporting Jython. We have recently acquired a new project lead for the Jython project, who is hopeful but doesn't want to make commitments based on past experience. But he's hopeful that he'll have Jython 2.2, which will be compatible with Python 2.2 in terms of feature set, and that's a very major step forward before the end of this year, probably in the third quarter even, is my guess.
Hi. I think on your blog you hinted at static typing, maybe? Could you comment on that and your thoughts?
The static typing is great food for thought. I don't expect much of that to make it into Python 3000. Some of the syntax may sort of be supported optionally. I doubt that we'll be doing much with it, and it's a really big thing. It's possible to accidentally sort of initiate a complete paradigm shift, and I'm rather in control of my paradigm shifts. I'm a bit of a control freak there.
Any changes to scoping?
Not very much. I think what's likely to happen is that there will be syntax so that you can assign to a variable in an outer scope. Like you have a function outer, which inside that there's a function inner. Currently, if you have a variable inside outer, then inner can reference that variable and it can call methods that might mutate it, but it cannot actually reassign to that variable. You will be able to do that. We're currently discussing whether the syntax should be the keyword global or some other keyword like maybe non-local, which is kind of iffy because it's a negative expression, or outer, or various other things have been considered. But that's pretty much the only change to scoping that I foresee. Possibly also, actually, we'll do something like do an analysis of whole module and look at which global variables we can detect are being defined there. And anything that is being defined, that's not explicitly defined or imported and not known to be built in, we can flag that as an error. And we can then also do a certain optimization where you say, well, if you're using len, and we know that len is a built-in, and you're not assigning to len anywhere inside this function, inside this module, we can actually generate more efficient code that just uses a new opcode that asks for the length of an object without actually doing a lookup of a function named len. And for certain built-ins, that would really make a lot of sense.
Will the threading model change? Will there still be a global interpreter lock?
There will very likely still be a global interpreter lock. If you don't like that, you can use Jython.
I have a follow-up on your answer to the question before about scoping. Mm-hmm. I'm surprised that you think you can make those optimizations, because I could in some other module, I could mutate this module and insert something called len. But you don't know when you're compiling this module that I did that.
Right. That is because that is technically legal, but it is morally frowned upon. And we're going to actually change the language rules a little bit so that if you just insert random names into other modules, that's not necessarily going to be accepted. Of course, you can, if a module has a global variable, everybody will still be able to give that global variable a different value, whether that's a good idea or not.
There must be code out there that legitimately does this.
There is code out there that legitimately does this with names that do not conflict with built-ins. I'm not sure that there's any code that anybody would actually be willing to show in public that does this for built-ins.
Hi, I have a question that came from a remote site, Santa Monica. It's asking you to comment on a specific feature. How about postfix if statements? They're allowed in list comprehensions. I don't see a wise reason not to allow them language-wide. It sure would make one-liners cleaner.
Well, what we add in Python 2.5 is not exactly a postfix if statement, but a conditional expression that has the form expression 1 if condition else expression 2. So the unique property of this syntax is that the condition is in the middle between the two branches. You can think of that as a postfix if, but it has it requires the else. So I don't think I want to add a postfix if to everything, like assignments or calls. That somehow that doesn't feel Pythonic to me. And maybe if you're new to the language and you come from a language that has that, you sorely miss it. But in general, I like to see my ifs when they apply to a whole statement to be upfront.
So I have kind of two questions. One is that there's always been this wacky syntax in Python where you can say low is less than x is less than high, and that gets munged into low is less than x and x is less than high. But I never hear anybody talk about that. Is that?
That's because it just works.
Okay. The other thing is there are all sorts of interesting new wacky things like transactional memory and replaying debug, like recording debuggers and stuff. Has any thought been given to that, in terms of Python 3?
Not specifically in terms of Python 3. It's not something I'm very familiar with myself. I actually have an intern who is interested in transactional memory. I think the PyPy project is a good place to look for that kind of thing, because they're building an entire new Python universe, which includes, or will soon include, a JIT compiler and all sorts of language transformations, where I think a reverse debugger might well be amongst their possibilities if they haven't already done it.